Hello. In this video, I'm going to talk about lung volumes and capacities. So first, what do those terms actually mean? Lung volume is simply a quantity of air. So we define and we describe the volumes in the lungs according to how much air we're taking in or pushing out or what's remaining in the lungs. So it's just different quantities of air as we engage in different aspects of respiration. Lung capacities are when we combine different lung volumes to describe functions. So lung volumes are more like the anatomy of it, like describing a quantity of air in a certain circumstance. And a lung capacity is more like describing, functionally speaking, how much air are we able to take in or push out and so on. And hopefully that will be made more clear as we go on and describe each one. So I like this image a lot. This shows each of the volumes and capacities that I'm going to describe here. So starting with tidal volume, that's just the volume of one breath in casual, easy breathing. So if we look in this graph, if we look all the way on the left side where you see tidal volume, you see that tiny little orange yellow arrow. So that's showing where that blue squiggly line is. It's showing that we just have this kind of very small in and out. That's our tidal volume. So just our casual, easy breath. So it's how much air is in just that casual, easy breath. The inspiratory reserve volume is any additional air that we can inhale by taking the very deepest breath we can. So if we look again in our graph here, here's inspiratory reserve volume. So that's above and beyond our normal tidal volume. So the normal amount of air that we breathe in. Above and beyond that, how much more air do we take in? So that additional volume is the inspiratory reserve volume. The expiratory reserve volume we see here, and that is how much air can we push out if we exhale and force out as much air as we possibly can. How much more air can we force out beyond just our normal easy exhalation that's part of our tidal breathing? Now you see that that expiratory reserve volume doesn't go all the way down to zero. Okay, so we only can exhale a certain amount. There's always going to be the residual volume that remains in the lungs. So that's the quantity of air that is still in the lungs and the whole respiratory tract after we have exhaled as much as we can, after we've released that expiratory reserve volume. That's the volume that still remains. So that residual volume is important because it's maintaining the space inside the lungs. We can never exhale all the way to zero because the lungs would collapse. If we exhaled to zero, that means that we're not maintaining any space inside our respiratory tract and inside the alveoli. And so all of it would collapse in on itself. So there will always be a residual volume, some amount of air that maintains the space inside the respiratory tract and prevents us from the tract from collapsing in on itself. And that's mechanically how it will work. It would be impossible to exhale that air because our breathing is all based on pressures. So we would never be able to get the pressure to the point where we could push out that air. That wouldn't be possible without severe injury. The inspiratory capacity. So now we've moved beyond the volumes, which in this graph, those are the little orange arrows. And now we're looking at capacity. So more functionally speaking, we're looking at how much air can we move in and out. So now we're adding volumes together to form capacities. And those are those purple arrows on the right side. So the inspiratory capacity, you can see in the graph here, and that includes the inspiratory reserve volume and the tidal volume. So if we add those together, that's the total amount that we are able to breathe in. So tidal volume plus inspiratory volume, that's the total amount we can breathe in from the bottom of our tidal breathing. So from just a casual light exhale, not from pushing out all of our air. The functional residual capacity we see down here. Okay, so that's the residual volume plus the expiratory reserve volume. So when we exhale during a normal tidal breathing, the functional residual capacity is how much air is left in the lungs that we could potentially push out, although we know the residual is not going anywhere. The vital capacity is this arrow here. So that's the sum of the inspiratory reserve volume, the tidal volume, and the expiratory reserve volume. So this is the total amount that we are able to breathe all the way deeply in and push all the way deeply out. That's the vital capacity. So functionally speaking, that's as much air as we can take all the way in and push all the way out. So we're not considering the residual volume there that we can never push all the way out. Total lung capacity includes all of it. So that would be the vital capacity, and then we add to that the residual volume. So that's basically the complete total amount of air the lungs can hold when they're completely all the way full, including the residual volume. All right, well, that's all I have for you in this video. Thanks so much for watching.